Morning, everyone. I'm seeing that the numbers are very low. I don't know if that means, should I expect people will be joining? Any indication of whether the whole class will be present? Can I get some indication whether there will be any? Well, I'll just proceed anyway, but can someone type in the chat? Do we expect more people to join? Because I'm about to cover a very technical, very, very subtle topic. Okay, so I think what we'll do is we'll first of all go through the work from last time. I gave you a number of exercises. And in those exercises, the goal was for you to flex your muscles at using the class construct to define a couple of classes, also to help you try and synthesize properties of these classes so that you had a natural class, a class that represents the particular entities that you are defining. So let me just go back to the notes. I'll just display this on my screen. Let me display my full screen so that you can see. Okay, and I will set myself at the bottom. Okay. So I just want to do an overview, make sure that everyone is on the same page. Because if you haven't done the assignment from last week, then you will struggle. Let me just be frank. You are going to struggle today. Um, okay, thank you, Florence. That's fine. We shall just move off. They will find us where they will find us. I think the videos encourage people to come late, which is a bit discouraging, but let's just go on. So last week we looked at a number of things. Let's just go over the slides. So this is inheritance. I don't want to do inheritance. So we started by framing the problem that we're going to be working on. We want to draw shapes and write text on a canvas. So you can imagine that this gray area here is a canvas. And on this canvas, we will draw shapes at whatever point in space. This is what I'd like us to accomplish. So we can draw a rectangle, a circle, another rectangle, a square, and have some text and have a background color associated with each of the shapes. So at the moment, it's very plain and simple. And this is usually a good approach whenever you're solving a programming problem that you want to solve the core problem first. You don't want to spend a lot of time and energy on details. You can add details or refine details until the cows come home. What you should focus on is what is the core problem? What is the core approach? What is the core use case? It's usually referred to as a use case. What is the core use case that needs to be solved? And when you solve the core use case, then you can tack on any number of refinements, whether it's animations or colors and so on and so forth. But here, as you can see, the colors are gray, there's nothing special. The text is red. We haven't even added the ability for users to think through the ability for users to make changes on those attributes. Because here we're really trying to solve the core problem. Can we represent a canvas, which is like a whiteboard or a blackboard, upon which we can draw shapes? That is a core problem. And we started off by thinking about a rectangle. A rectangle has got, it's got a width and a height. Those are most salient properties. And for it to be drawn on a canvas, we need to know its position. So we assume that it is located at the origin. Now, that is a bit ambiguous because it doesn't tell us what part of the rectangle is at the origin. Is it one of the vertices or is it the center of the rectangle? In any case, it doesn't really matter. What matters is that we can capture this key information here. Once you have a rectangle, then you can synthesize certain features about the rectangle. You can calculate its area, you can calculate its perimeter, you can calculate the length of the diagonal, and you can calculate the bounding box containing the rectangle. And we are using the class construct, and whatever you've seen on the screen in front of you, this is exactly what we would write. So what you see on the right here is an actual rectangle I've created with a width and a height and a fill and a stroke and a position. And all those attributes are added into it. And then we have an area, which is calculated based on the attributes, the width and the height. And we have a perimeter, which is again calculated based on that. Oh, so this is actually wrong. So this should be self plus width plus height times 2. That's an error. Okay, and then the bounding box has got an x minimum, x maximum, which just defines those 4 values, x min. Okay, and then the diagonal, and there are many ways you could define a bounding box. Here we're using the bottom left and the top right to define it completely. The diagonal, we calculate it using Pythagoras equation, which is the square root of the sum of the squares. And then we talked about, okay, then, so once you have the skeleton, add those methods. The methods are the operations that are native to the rectangle. And then additionally, we thought about the fill and the stroke. So fill is the color that is inside a shape. Stroke is the color that defines the boundary. And you can add other attributes to that. For example, you could have, for the fill, you could have an opacity, which is how transparent it is. And for the stroke, you could have a width. But we're not adding that for now. We're just trying to solve the core problem. Because once you solve the core problem, adding things on top is quite straightforward. Okay, so then we want to implement a canvas class, and the canvas class is what you see here. It's very basic. It's just a canvas class with a width and a height. And as we go through today, we shall be adding additional attributes and methods to this class. And then we talked about a text class. Text class is very simple. It's just what is the text that we want to print? What is the position? Oh, we could also add the color of the text. The color of the text, and by default we are going to choose red. So we're going to use a hex color system for that. Or let me just use red and make it simple. And we save that as the color. There we go. Okay, so now we have text, and then we shifted gears and we talked about drawing with turtles. And the idea behind drawing with turtles is it's an excellent way to show you the step-by-step process required to actually draw using some primitives. So here we're using a library called Turtle. It's part of the Python standard library. It's available at that link. And it has 2 big primary classes. One class which is called turtle.turtlescreen, which I think we should look at the documentation. Docs. python.org library/turtle. And if you look for the turtle screen class, turtle screen, if I can type. So the turtle screen class, okay, so I can click on this. It doesn't. Methods of the turtle screen class. There we go. So this is the main thing, and it takes a canvas. It provides the screen-oriented methods for like background color, etc. So there are so many methods. We looked at that briefly at the beginning when we saw what can you do with Turtle. You can, yeah, there's all these things you can do. There's a visibility, there's colors, and then methods on the Turtle screen or the screen class, background color, background picture, clear screen, reset screen. That is essentially your canvas. Okay, so coming back here. So Turtle screen is for drawing, and then the raw Turtle class, turtle, the raw turtle. Here's a raw turtle, which takes a canvas, and it is actually it's the pen. It's the pen that actually draws. So there are actually two names. There's raw pen and there's raw turtle, and they are essentially the same thing. This is just an alias for the turtle screen class. Okay, so the raw turtle or raw pen, I've just discovered that they renamed it, which is good. I don't think it was called that before. And it has all the methods associated with writing. Okay, so that's it for, and then we looked at some examples. I gave you some exercises to try and draw a rectangle. So this is a simple rectangle, and it will always start from the origin, but you can tell it where to start from. And then we drew a circle. I think we have some examples in, oh, I created a new module. So these are all available on the repository. So if you go to Paul Korir programming underscore for underscore engineers, so go to github.com. And I showed you this in the first class, how to connect your PyCharm to Git and using Git and GitHub so that you can just pull what you need. So here is the repository, and it's got everything. I haven't added the latest changes. Let me just see what this is. This is a So I'll just add tiny edit, and I will push this. So I've just pushed that. So it's just committed just now. So the OOP circle is where all those classes are. And you should pull this for you to start working today. If you're going to start working today, you haven't done any of these. The disadvantage for you, because obviously you haven't stretched your muscles and learned the intricacies of using these constructs. But for you to make any progress today, you'll need to have this code. Otherwise, if you're just going to watch it and postpone the time when you're going to write this code, you will not find the time. That's how life works. Okay, so the draw circle, let's just look at that, drawing with turtles. So there's the draw rectangle. I changed the values there just to make sure that the rectangle is big enough. And then the draw circle, we start off with a turtle, and then we set the pen up, and then we go to a certain location. So pen.go to. This is different from the drawing the rectangle. When we're drawing the rectangle, if you look at what's on the left of your screen, we started off, we assumed the position of the turtle. But in the second example where where we're drawing a circle, we tell it where to start from. So now it's starting from the location 1528, and then we put it down, and then you begin to fill and draw. Okay, so these are the simple primitives when it comes to working with shapes. And I gave you an exercise: draw a triangle, draw a pentagon, and write some text. Okay, so today we are dealing with object-oriented programming inheritance. So this is going to be very different. So I want you to really, really pay attention, and we're going to walk through step by step. So before I make any progress, I just want to find out, do we have any questions? I don't want to proceed if there's something that is not clear. So please ask a question now or forever hold your peace. Any questions? There's no such thing as a dumb question. Except the question, should I ask a question? I think that's a dumb question. But ask a question, go on. So everyone is clear. So if everyone is clear, can I get a thumbs up from everyone? Okay, thank you, Owen. Thank you, Timon. Thank you, Molo. Thank you, Florence. The rest, okay, then thank you, Mishak. Thank you, Patience. Okay, I've only got about a, okay, thank you, Darren. Anyone else? Okay, then if you are stuck and confused, can I see a thumbs down? Thank you, Bellamy. Thank you, Beniza. Thank you, Gate. If you are stuck, can I get a thumbs down? A thumbs down. If you're completely lost, can I get a thumbs down? No thumbs down. That's great. Everyone understands. Okay, great. Okay, then let's move on. Okay, so today we are talking about, so just a quick recap. We've looked at the def construct. We look at that on day 3. The def construct essentially amounts to giving a block of code a name. That's what we call a function. We want to reuse that code. We are giving that block a name, and we can pass to it some attributes, some parameters or arguments that control how that block of code works. So look at this example here. On my right, what I'm highlighting, let me just make sure that you're seeing what I'm seeing. So the draw rectangle is like every other construct in Python. It's a code block which has a header and a suite. And the suite is indented, one indent inside, and it's a set of instructions. And that set of instructions, we've given it a name. We've called it draw rectangle. Now, at the moment, we haven't assigned any arguments that control how this block is used. We can call the draw rectangle function as many times as we want. We don't have to rewrite that code anymore. We simply have changed it from being a block of code that we could run only once to a named block of code. We have set it aside, and we can now call that as many times as we want. I don't know who this is. Is the meeting on? Um, I don't know who that is. That's strange. Okay. Um, So that is a def construct. The class construct does something very different. So you recall when we started, we talked about TOC, types, operations, and constructs. And types and operations went together. For every type, you had a set of operations. For example, for integer types, you had arithmetical operations. For string types, you had the string. There were some operations, some of which are expressed using operators, and most of them are expressed using methods. So string methods are the ways in which you play around with strings. So the types and operations go together. The constructs are the things that allow us to use, oh, someone is, constructs are things that the language provides for us for free. Now, the thing about the class construct is it allows you to create your own types. That's the whole point of having classes. You're creating your own types. And so whenever you define your own class, you are in charge of what you're going to define as the name of the class, which is the name of the type, the attributes that that type will take, the methods or the operations that it will have. So a class contract is just an attribute container, and it has methods which are functions that act on instances of the class. Remember, instances is another name for objects. So when you have a class is a template. Let's look at this picture here. The class is the template, and the thing that you make is the like the cookies that you cut using a cookie cutter. Those are the objects, and each object we call is an instance of the class. What I'd like you to do is just write those words down and memorize them. And just memorize them so that you have them every time in your mind, you know what they're referring to. Okay. So that is this beginning idea there. So far we have created 3 additional classes. We've created a rectangle class, we've created a canvas class, and we've created a text class. They're very basic right now. Now we have drawn with turtles using the turtle library. Now we are going to take it to the next level. Okay, what is inheritance? So this is now where we now get into inheritance and start thinking about inheritance. So inheritance, and it's unfortunate, I have these, the content of these slides, all of it comes at once. I don't want to distract you. So what I'm going to do is I'm going to put an animation. I will put an animation on this slide because I want the ideas to come one at a time. Let's just see if I can do that quickly. Format, insert, animation, and I will by paragraph so that every time I talk, you can just see them one at a time. I like it that way. Okay, so inheritance is the ability to borrow properties, whether these are attributes or methods, from other classes. So remember, we said a class is the construct, and the class has got the attributes and the methods, which are the operations for that class. The class is a new type. So with inheritance, you can make a type or a template, and then instead of creating that template again, you can make a copy or an extension of that type by borrowing from the previous type. And the beautiful thing is that this ability is not just confined to the types that you create or the classes you create, it even applies to what has been provided by Python. So for example, for a string class, the strings that you use from Python, you can actually extend them. You can make a new type of string, and that new type of string can have very different behaviors. You can modify certain things about it. For example, I created a library it's called styled, styled. You can find it on the let me actually show you because I think it's instructive. So let me show you. There's a styled library. I think it's styled. No, it's not here. And I think it's instructive to show styled. Let's see if we can find that styled. Empire. Oh, wow, doesn't show up. I think it's an underscore. Okay, EMDB Empire, let's just go here. And we're looking for the styled library. So SFTK, styled. Here's a styled library. And if you look inside, this is a lot of, so this is a library itself. And inside the library, let me just zoom in. We have the styled, and we have made a string class. So this is a styled. It's supposed to borrow from a string. So this one behaves differently. Let's just 1 second. Assets, style name. But this is essentially behaving like a string. So here we are borrowing from something, but this is supposed to, I don't know when I modified this, but that's a class. And I think in a previous version, it was borrowing from a string class. Okay. So essentially what you can do is you can borrow behavior. Let me come back here. Yeah, you can borrow behavior from other classes. We are borrowing properties from other classes. And this really is where object-oriented programming shines. It allows you to invest time into building a good class. And rather than saying, okay, let me start again, just say, oh, I've done all this work. Now that I've done all this work, I could just borrow it and take it and use it somewhere else and then keep on improving it. And I can actually build a tree of different classes and how they're related to one another. Okay, and that's really, really where it shines. So once you define a class, you can create other classes from that class. The child class, so you have a class and then you make another one. The other one you create is called a child. So it's a child class. That's why we have a tree. We'll have all the properties of the parent class. So initially, it'll be an exact copy of the parent class by default. And now you can overwrite these properties if you like. And I'm going to show you how we'll do that using some special features of the language. You can access properties of the parent class. In other words, within the child, you can refer to things that were present in the parent class. And you need a good understanding of the domain. So it usually involves having a clear understanding of how things relate in the domain. Now, what do I mean by domain here? Let's take an example of, suppose you are writing accounting software. So accounting is the domain. It's the field of application. Engineering, electrical engineering, civil engineering, whatever engineering, that is a domain. It's a domain. There's a set of ideas, entities that relate to one another. And those entities are now could be the classes. They don't have to be. Right? It takes time to understand, like, how do you make the right kinds of classes? But once you understand the domain, then you understand the relationships between entities in the domain. Typically, you'll make your entities will be classes, but at the same time, you don't want everything to be a class. You want to be judicious in your choice of classes. There should be a very strong relationship between a parent and a child. And that kind of relationship is, you want a coherent relationship, a relationship such that the parent and the class, for the most part, behave in the same way. We'll look at an example of this very shortly. Usually, a child is a special case of the parent class. And again, we'll see that in this. So recall from our rectangle class, I'd like us now to create, so this is an exercise, I'll give you about 10 minutes while I go and grab a cup of tea. Create a similar class for square by copying and pasting the rectangle class code. In what ways does a square class differ from the rectangle class? So I would like you to, literally, we are not doing any inheritance at the moment. I just want you to make a new class called square. And in your class called square, create that class so that you can actually instantiate a square object. And then I'd like you to do a side-by-side comparison. I wish I could put you into groups. You know what I'm going to do? I'll actually put you into groups. Let's see if I can. Breakout rooms, great. I'm going to make breakout groups, and I want you to try this out together, okay? So I will create, let me see how many you are. You are, at the moment, you are 43. I'm going to create groups of, so I think groups of 3. So that means I'm creating about 10, 11 groups. No. 36 would be 12. Let's say I'll create 13, 14 groups. So I'm going to create 14 breakout groups, and I'll assign you randomly. And okay, great, that's good. And I want you to try this out together in your groups, okay? So you're randomly assigned, and I'm going to open all rooms, and I will, please join the groups, breakout groups. And for the next 10 minutes, I want you to try and make a square class using the code that we've created so far. You can share your screens amongst one another. There's no recording happens within the group. So go into the groups and work on this. Okay, hello everyone. So, anyone willing to share what they discussed? Hello? Okay, so we'll just proceed. Okay then. So, I will create the code for you. I don't know if that will be helpful to you, but let's just, so a square class, if we were to create a square class, um, so this is different. This is one which would have inheritance, class square. If you created a square class, so let's hide this for now. Well, we'd expect a square. The only thing about a square compared to a rectangle is that a square only takes one length parameter. So our depth and under init and under, and it will be self width, and that's all you need. And then you can now copy the other attributes. We want it to be a white fill. We want it to be a black stroke. And we assume again its position is at the origin. And then we can set the width as the width. And we can set the fill as the fill. We can set the stroke as the stroke. And we can set the position. Okay. And again, we can have the same methods. We can define the area. I just do the one for the area, which will be return the product of the width. Actually, we just square it. Same thing for the perimeter and same thing for the bounding box and the diagonal. Those are all derived in similar ways, and I'm not going to go through that. But that's essentially what you'd have. And then now we can instantiate a square. So I want to instantiate a square object. And I say square is equals to square. And all we have to give it is the width. We don't need to specify these other attributes. And now we can print the square, or we can have the string depth under string, which would be return f square of, and we can say self.width times self.width. Full stop. Okay, I don't make that a sentence. So we can create a square, we can print the square. Notice what we are doing is we are literally printing the square itself, which means the string will be coerced. If you remember from lesson number 2, it will be coerced into a string by calling this under string method. And then we can also print the area of the square. So if I say f square dot area and equals, okay, so if I run this now, we will see square, and that's the dimension of square, and this, we are printing the method directly, so it tells us what it is. It's a bound method. We don't want that. We want to actually show the value. So run it again, we see square is 5 times 5, and the area is equals to 25. Okay, so that's it for how we create a square, but now we want to do it using inheritance. And to use it do that using inheritance is we borrow from the rectangle. So what I'll do here is I'm going to comment this out, and I'm going to uncomment this. Now, I'm going to take you through this step by step because it's a lot of new things here. So first of all, whenever we define an inheritance relationship, unlike with a plain class, so with a plain class, we simply, let me just highlight this on the screen for you. For a plain class, we will just use a colon at the end of the class name. And then at the end of the class name, that will just be a plain class. But if we want to inherit, we then specify within parentheses the class from which we are borrowing. Now, let's see that here. We are borrowing from a rectangle, and because we are borrowing from a rectangle, we have to now compare what is the initialization of a rectangle in relation to a square. When we defined the initializer here for the square, we only had one dimension attribute, which was the width. But a rectangle is different because a rectangle takes more than one. Let me just clear this. A rectangle takes more than one. So if you look here, a rectangle takes both a width and a height. So if we're going to borrow from the rectangle, try and take advantage of everything else that's available, the area method, the perimeter method, the bounding box method, the diagonal method, then internally, as we are doing this instantiation, then we need to make some modification. But we have to make reference to the parent class. And this is where the super method comes in. So super, as I'm highlighting it on your screen here on the left, super is a way for you to refer to the parent class. And it does it in a clever way. I won't go into all the details, but suffice it to say that whenever you have a class, so Python is a special language because you can have multiple parents. So what super does is it does a resolution on the parent classes. But in our case, it's very simple. We only have one parent class, which is the rectangle class here. And this is the child class, as we said before. There's a child borrowing from the parent, but we want to make reference to the parent. So we call super to define. Just say, essentially, we could even use the name rectangle, the class name itself, but we don't want to do that. We want to do it in a clever way that is programmatic. So here we call super, and we then make reference to its initializer. Now, in the initializer, we had for the rectangle, the initializer for rectangle, as we said before, it's under init, self, and its width, height, fill, stroke, position. Okay? Now, in the child class, what we are going to do instead is we'll say, okay, then we'll ask the user for only one dimension, the width. But when we call the parent class, we will duplicate the width because a rectangle is essentially a square that has both sides having the same dimension. So here we have super, which is in reference to rectangle, dot. We are now accessing the methods and operations available on that parent class. And then we call under init. And then we just pass the arguments as we receive them. So here is width and here is width. And we just duplicate width. We now have another width, which is the height. And then we pass everything else, the fill, the position, and everything else. I think I forgot stroke here. So I think stroke, let's say, is black. And I'm going to put stroke. Now, notice something else here, and this is very instructive. Whenever I say fill here, I just reference this variable fill. So I'm essentially saying set the fill for the parent class to be the fill that came in from the child class initializer. So this is a child class initializer. We have specified a fill, a stroke. It may be the case that the child class has different initial values for the fill and the stroke and the position. And we'll just pass those through, okay? Now, I want to show you how it really, really shines. So now we have a square instance. We've specified a width of 5. Let's see what happens. I don't know if I had I don't think I didn't have, okay, so I'm going to just copy and paste this here. So I'm going to assign it as the under str method of the rectangle. Sorry, I'm commenting that and I say rectangle with width and height. Rectangle, if I can spell. Okay, so if we run this again now, again, get the same thing. Notice we haven't changed anything. We have uncommented that. So now we are using this other code block here. So now we still get that the rectangle, so now we are calling it a rectangle. So it's a rectangle with equal dimensions, We can work on that later. That's not really critical. But we can get the area without defining an area method. We simply borrowed the area method. Now, let's just try and do something that shows that we can modify this. So what we could do here, suppose we wanted the under str to be, to be faithful to the fact that this is actually a square. So now what we have done is we have overwritten. So let me just make this as a comment here. We have overwritten the under str method. In other words, we shall not reference, we are not going to rely on the previous one from the parent. And notice on PyCharm, it shows this little symbol here. If I click on that, it actually then goes to the parent class. So this shows here that this is a nice thing about using an IDE as opposed to just a plain text editor. It shows you where you have these special behaviors of overwriting class methods. So let me just see. If I hover, it says overrides a method in rectangle class. And that's very instructive there. So now if I run that again, it doesn't call it a rectangle, it calls it a square. And it calls it a square because the under str method has been overwritten in the child class. Okay, I'm going to commit this and I'm going to push and then I'll say inherited rectangle into square. And I will push and commit. Let's just push that up. Okay, so if you pull it now, you should get that change, those changes. Okay, so that's it, at least for the beginning. So we've seen the beginning of what inheritance looks like. Now, I want to introduce a new thing here, which will again remove a lot of the boilerplate and repetitive writing of code. Now, observe within the rectangle init signature, it had this. It was def, init, self, width, height, with a fill and a stroke. It was different in ours. We were actually using strings to define the colors, a string, a fill, and a stroke in a position. When we call super, we have now written here, super, init, fill, width, whatever. Okay, you see all that? Let me just look at that. I'll show you again. So here we have to copy everything. Now, suppose that we needed to add a new attribute, a new argument to the initializer signature. So we wanted in rectangle, let's do this practically. So we have rectangle, it has 1, 2, 3, 4, 5 arguments. And we want to add one more. Now suppose that we had 5 subclasses of rectangle, okay? 5 subclasses of rectangle, so that it was not just square, we had different child classes. We don't have to know what those are now. I just want you to play along. And then we said, okay, hey, look, we've got a fill, and now we want to have the stroke width. And we say that that is going to, we'll instantiate, that is going to be, I will just say that is 1, okay? And now we're going to add that. So we have stroke and we have self.stroke width is equals to stroke width. Okay, so there we now have a new, but what happens for all the children? For all the children, you have to go through all the children and add. So now we'd have to come here to the square class and say, oh my, now we have a stroke width. So we have to go here, stroke width is equals to, and we set what the stroke width is for a square. And we come here and we again have to pass that stroke width is equals to stroke width. Oh, that's a lot of work. Oh my goodness. Now that's tedious. I don't know why it's giving me a run. Okay, let's just undo that. I don't know what I did there. Position is equal to position. Okay, stroke. Okay, so, and then I have to do it for the other 4 subclasses, 4 child classes. Every time we'd add a new argument, we'd have to change super. And that's boring, that's tedious. And this is where the star args, double star quargs comes in. What star args and double star quargs, if you read through the fourth section of the quick wins, code quick wins, you will have seen this before. So this should not be surprising to you. If you haven't read that, then you obviously it will be surprising to you. And what this refers to, these are the positional arguments. So the first one here is positional arguments. So these are positional arguments, and these are keyword arguments, which is why you have the K. K stands for keyword arguments. So these are positional args, and these other ones here are keyword arguments. I'll just say args. And keyword arguments are the ones that have an equal sign between them. Okay. Okay. So let's see how to actually use this. Clear that. It's now just putting text everywhere. So Python provides a shorthand so that instead of writing super init with fill stroke blah blah blah, you simply write super init, and then you put the positional arguments that you are modifying. This is now where it gets complicated, and this is where the nuance is. And then all other arguments and keyword arguments are just replaced using this. And Python is smart enough to then carry over anything that needs to be passed along. So let's do that practically. So here we've defined that our square has got fill and stroke width and position, and we are passing this on. And so instead here, what we do is, instead of going through the rigmarole of writing all that, we can just write pass any arguments and pass any keyword arguments on. Just pass them on, okay? Why is it giving me that? Well, if I just do the quads for now, because I know we do have keyword arguments, that should be okay. But I think it's because quads. Okay. It should have been specified on the initializer. So we have width here, and so if we define that we shall have an args here, and so it behaves just like any other variables, args and quags. So what we're essentially saying now is that whenever you define a square, you need to at least specify the width. And then everything else, just pass them on as they are, okay? Pass them on to the parent class. And so what will happen here is we shall have the width, and then the height, which will be the width again. And then anything else that comes in, we shall just pass it as it is. So star arg stands for all positional arguments. The star is actually a way of unpacking. I don't want to go into details of that, but that's how you unpack. So let's run this again and see how it behaves. So we notice no changes here, but the beautiful thing is now we can add as many keyword arguments or new arguments here, and they will always just be faithfully passed along from the rectangle class to the parent class. Okay. So now that we have the basic ideas, I'm going to pause here. I'll just give you, because I'm noticing you're not asking any questions. You're not engaging at all. So I'm not going to give too much time. Do we have any questions? Do we have any questions? Any questions? Please type them in the chat. Any questions, any comments, any complications? None. Okay, then let's proceed. So now we've seen how to do this with a square, borrowing from a rectangle. Now the same thing will apply with these special classes. We introduced them last time, that there was the turtle screen class, which we said was where to draw. This represents the canvas. So if you actually look at the documentation, it actually treats it like a canvas. Well, it assumes that it's going to get a canvas. And then we'll now figure out how to get the canvas. So we'll walk through this. So that was for the turtle screen. Now, for you to get a canvas, it actually provides a canvas. There's a method called turtle.getCanvas, which we can then pass. So this then, our turtle screen will then take that canvas, and that's how we will write this. So it's going to make sense in a few minutes. Okay, so let's actually do some coding now. So now we had our canvas class. So we had our canvas class. Where is our canvas class? Okay, and now we're going to inherit from turtle. So now we're going to import turtle. And we shall now extend our canvas class. So we'll extend it using the turtle screen provided there by IDE. And it have a width and a height. We can give it a background color. Remember, we had said it would have a background color. Background color would be, let's call it just white. And now we can now call. So this is what we are going to do. So so we know where to get the canvas from. We said from the previous screen that there is a get canvas function that's available on this library. So when we're defining this, since we have specified, okay, so we initialize that there. And then now we shall refer to the parent class, super dot under init, and we shall pass the canvas, okay? And where do we get the canvas? We said we get the canvas, so we shall get this before we start. So we get the canvas is equals to turtle dot get canvas. And now we can pass the canvas on, okay? And after the call to super, canvas has a turtle screen attribute, okay? And we can then set the screen size. So let's go to the documentation and see how that is done. So just walk through this. So we have the turtle screen, and it has got a couple of methods. Let's just find the screen size. We're looking for the screen size. We can specify the screen size. There's a lot of methods in here. So there is a screen size here, which takes the canvas width, a positive integer, and the new width in the canvas pixels. The canvas height, by default, it's none. It's a positive integer, which is the new height of the canvas in pixels, and the background color. So now we can set the screen size. Let's just try and figure this out. So turtle dot screen size will pass the width and the height. We can store the width and the height in any case. Let's just move these up because those will be attributes we'll rely on. And the background color is the background color we have there. So it's either a color string. So this is what it says, color string, or a color tuple. The color tuple would be RGB, 3 numbers, which will be the new background color. Okay. So let's come back here. And then we store the width and the height. We've stored them already. They're part of for future reference. So now the task is, so we have a canvas. We want to set the screen size to a width of 1200 by that, and we store the width in the instance. So let's just see what that looks like. Well, the second thing we'll do is the pen, but this is it for now. So here we go. We set what the canvas is, and we set what the screen size is. What I don't know is what this returns. Return the canvas height and width. Else resize the canvas. But what I don't really know, and not clear to me here is, so screen size, that sets the screen size that, screen size, and it returns a tuple. Returns a height and width. Okay then. But those are values we've already set. Okay, so let's see. Okay, at the moment we can't really do anything with that. And we'll keep building upon this, and let's just keep going. So this is idea number one. Idea number one here is that we've created a canvas. We have borrowed from the turtle screen. We have created the canvas. We have using the get canvas method. And then we have set the screen size. We have set the screen size, that should be to be that particular size. So the thing that's not clear to me in my mind right now is, so we've set the screen size, but how has that been assigned to the canvas? We'll get to that eventually anyway. But this is idea number one, okay? Now, let's move to idea number two. So we've done with the canvas. Now we need to make the pen, okay? So I'll use the values here. We have an initial width of 1200. So I'll set that initial width to be 1200 so that the user doesn't have to, and height of 750. So these have to be positive integers. Let's just play it safe. Now, remember there are two ideas. One was the turtle screen, where to draw, and the second thing was the pen, what to draw with. The raw turtle or the raw pen, as you saw from the library. Pen was the actual turtle. I'll leave this for you as an exercise, the difference between turtle and raw turtle. I'm going to go into that right now. Now we need to add an attribute pen to the canvas class and instantiate the correct object. So let's go back to the documentation. We need a pen, so we need to have a self.pen. And the question is, where do we get that pen? So let's come back to the documentation, and we see it was the turtle, raw turtle, raw turtle. So the raw turtle, let's see how to instantiate one. So that's a raw turtle, and it takes a canvas. So what we need to do is we also need to assign this to an argument here. So self.canvas is that, and we refer to self.canvas. So now we have a canvas that we can refer to, okay? And now for the pen, we'll say it's turtle.raw turtle, or raw pen, doesn't really matter. Let's use raw pen, and it will give it self.canvas so that it needs a canvas. It creates a turtle, and the turtle has all the methods defined above. It doesn't return anything. It just recreates the pen. So now we have the pen defined on the canvas. I'm going to pause there. Any questions? This is all building up towards something. So I need your patience here. Any questions? Any questions? Are we following along? Or at least are we copying along as we go? No response. Okay, so now we've added the pen, and we're going to create a mystery method, and we're going to add it to the canvas class. So this is a method. I'm just going to call it mystery method for now. Def mystery method. And self. Now we are referring to the pen, self.pen.up, self.pen.goto, 0, self.height, divide by 2. What does this do? And then self.pen.down, self.pen.goto, 0 minus self.height, divide by 2, self.pen.up, self.pen.goto, minus self.width, divide by 2, 0, and then self.pen.up, self.pen.home. So there's a method called home. Let's see what that does. So home, send your turtle back to its starting point. This method does not return anything. So we'll just use it as this. So let's see if this works. This could fail. I'm going to create a canvas, and I'm going to call the mystery method, and let's see if that works. So I'm going to create that here. So now we're going to do some drawing. So canvas, canvas is equals to canvas, and I'm going to call the method. So canvas.mystery method. So let's see if this works. It could fail. Okay, that seems to work. Okay, I think I forgot a pen down somewhere. So I have a pen up, go to, a pen down, go to, pen up, go to, there should be how many lines? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, I have fewer lines here, so that's why it's not drawing something. There's something missing. Self.width divided by 2. I think I missed. There's a self dot pen down, and then there's a self.pen.goto, self.width, let's divide by 2, 0. Okay, and then that's a pen up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I run that again, so that's what that does. Unfortunately, let me do it again and try and put it on the screen. So you can see it's drawing on my screen. So I'm going to commit this and push a working canvas. So I've pushed that. If you pull that from the repository, you gotta go back, 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 back. So now we have, if you check this out from the repository, we have a canvas with a turtle screen, and there's a mystery method. So just pull that git pull, or you use Command T or Control T on your repository, and then pull the code. I'd like you to run it now. So I'll give you 5 minutes to run this just to make sure you understand what's going on. 5 minutes to run this. Okay, I'm trying to figure out something here because I'm not seeing that my canvas has the size that I want it to have. Because I have the width and height as 1200 and 750, but what I'm getting is not, I think I'm using the default. So for whatever reason, it's not doing what I want it to do, and I need to figure that one out. So the screen size, this is supposed to set the screen size, and for some reason, it's not doing that. Okay, well, I know these two go together, but I don't know. It should give me a change, so it's not doing that. I'll fix that. I'll figure out what's going on. Okay, that's fine. So now we have a pen and hopefully you've gotten it to work. So you should see drawing on the screen a little cross, which is what I wanted you to do. Now we do have about 40 minutes till the end of the class. There are two options here. One is I continue with polymorphism, as if you're not confused enough, or we postpone this until the next class. And so we either spend some time doing some exercises and trying to figure things out, and you can ask questions or we pause here and then we continue. So I'm going to write three things in the chat and I want you to put a thumbs up on each of them exclusively. So either we pause here and do exercises. So this is option one, or we continue with polymorphism, or we take a break and you can, do exercises on your own. So can I get thumbs up on each of those options? Actually, I wish I had done it as a poll. I can do it as a poll. What would you like? Can I get thumbs up on each of those options? Break. Okay, more break. So break is winning. Pause here and do exercises. Okay, great. Continue with, okay. Okay, so seems at the moment that there's a majority who want to, okay, it's a 50-50. So we're definitely not continuing with polymorphism, but there are 36 of you and I'm only seeing 8 votes. I don't know if these are unmanned terminals. It's very discouraging. I'll be honest with you. It's very discouraging to wake up early in the morning, prepare material, and there's absolutely no engagement. It is genuinely discouraging. Okay, one person wants polymorphism. I want to see 36 votes or 35 since I'm included in the participants. Otherwise, it gives me the impression that the bulk of the class is completely disengaged. And that's fine. It's totally fine. Maybe you don't want to learn programming at all, and you are perfectly fine with that is perfectly fine. There's no harm at all. Okay. So this is what we'll do. I will, this is what we'll do. I will continue with exercises. I'm available till the end of the hour. Those who'd like to take a break are free to take a break, and we will not continue with polymorphism. So if you want to take a break, feel free to drop off the call, and hopefully those who remain can now be more engaged and we can ask and answer questions until the end for anything that is not clear. Okay, so for those who are dropping off, bye, and I'll see you next time. I think we're meeting tomorrow at 2 for polymorphism. Okay, then. So for the exercises, I'd love questions. Throw in your questions into the chat. Or unmic yourself and let's try and drill to the bottom of things that you may not be clear about. I'm not going to proceed with polymorphism, but we can do other exercises. If you have a particular question, I can create something on the fly. Any questions? Anything that's not clear? What args and quags do? Okay, good question. Very good question. So args and quags, thank you for that question. I'm going to give you a thumbs up. And if other people can also give him a thumbs up and encourage Jordan. So args and quags are a shorthand for you. And thank you, Omolo, for the question. I haven't understood how the pen works. Okay, that's fine. I'll come to that question. So what args and quags does, whenever you have args and quags, you are trying to avoid repeating yourself. So let's look at this example. I'll just come back to where we used the args and the quags. And what I'm going to do, actually, I'm going to just minimize everything so that we can only see the things we want to see. So we had the rectangle here. The rectangle was defined so that it had the width, the height, the fill, and so on, okay? And then we said, we want to make a square, and that square, we want that square to borrow from the rectangle. And we want to, we will take advantage of everything else available on a rectangle. The only thing is that whenever we define a square, because we know a square has got the same dimension on both sides, we don't have to define both sides. Like if you say a square, I'm defining a square with sides 5 centimeters by 5 centimeters. That is redundant. You've said more than you need to. So when you define a square, you simply say a square of 5 centimeters. Same thing if you're talking about an equilateral triangle. Like the fact that you call it an equilateral triangle means that all the sides are equal. So the dimensions of an equilateral triangle is just one number. That number specifies all 3 sides. So with the square, since we're borrowing from the rectangle, the problem is that we don't want to have to now repeat that we have the fill and the stroke width and the position. That's on the one hand. But at the same time, we want to have the freedom to keep changing the rectangle class so that the rectangle class is, we can add new arguments as and when we need them. And so what we do is we can replace, in fact, if you really wanted to be, that would be too complicated. Let's keep it simple for now. So here we have all these arguments. We've got the width and the height and the fill and the stroke width and the position. And when we define the square now, we just say, just treat all the arguments, just use this shorthand. And we shall pass this shorthand around, which means we can add new arguments here. So let's just think of one we can add. Let's say the opacity, okay? Opacity. And we give it a value between 0 and 1. So we'll say opacity is, let's say by default is 1.0. In other words, it's completely opaque. An opacity of 1.0 means fully opaque. Opacity of 0 means it's fully transparent. And an opacity of 0.5 means you can kind of see through it. But now we've added a new thing, okay, a new attribute. We'll obviously need to save it. Self.opacity is equals to opacity. But notice we don't have to make any change to the square. Now let's actually do that. So I'm going to comment this part here is going to activate. I don't want to activate that. But now we have square. If I run this, we'll see we have our square, but we didn't define opacity as an argument or attribute on the square. But if we check for the opacity, print square.opacity, and we run that, we now have opacity automatically. In fact, let's even do something else which actually shows how the args, quags will work. We can now set opacity here. And notice Python is smart enough, PyCharm is smart enough to notice that because the square is inheriting from rectangle, but we have only specified args, quags, it knows that opacity is available on the square class. So now we can specify opacity as 0.5 and it'll just be passed through. It'll just be taken through. So now when we do that, we have an opacity of 0.5. So the args quags is just a shorthand for saying in the child, either in the child method, just take everything that we get and pass them up. Now there is some method to using them. And this is now where you will, as you play around with it, you'll begin to find little ways of modifying how it behaves. So let me try and do a bit of that here. I will unpack. I will print out what args is, and you'll see what it is. I will print out args. Args. Now, when I'm referring to it, I'll just refer to it fully as it is. I don't use the star. The star is specifically for unpacking. I'll show you how that works in a second. And here I'll print f quarks. Now, if I run this, now the difference now is that you will see that args is an empty tuple. So this is actually a tuple. A tuple is it's like a list, behaves a lot like a list, but the only difference is it has a property called immutability. Once you create a tuple, you can't change it. You can create a new tuple from that. While a list is a mutable sequence, once you create a list, you can always modify the list. And the quark is actually a dictionary. And this is now where you begin to see the funny things about it. So let's do something else here. Let's create a new method which will illustrate the behavior of, I'm just trying to see how to do this. Because I want to show you what the star does. It's not a pointer, it's just an unpacking operator. It unpacks the content. Okay, let's just do a fake method. And it'll be self, and it'll take something, okay? Now, let's do this. A, B, C, D, okay? I have 4 arguments here, 4 arguments to this, okay? And I'm going to print them out. I'm going to print A, B, C, D, okay? There we go. This is just a quick illustration method, and I'll use it here. So I'd say print F, and I'll say square dot fake method, and I'll call it, okay? So if I run this, okay then. So it takes four items. So this is now where it gets interesting. So I'll give it 1, 2, 3, 4, okay? So if I run that, the fake method, it returns none, but it prints out A, B, C, D, which is what we wanted to see here. It prints out A, B, C, D, okay? Do you see that? Now, let's do something different. Suppose I make a list. I'm going to comment it. I want to illustrate what the star is doing. If I create a list, my list, and I have the values 1, 2, 3, 4, okay? Now I can't, or let's make them a tuple. It's just a sequence. It's just that we use parentheses instead. If I wanted to pass these 4 values to the fake method, I cannot give it my list. So if I say square dot fake method, if I give it my list, it's going to my tuple. Let's call that my tuple, just for consistency, my tuple. If I run this, it's going to give me an error because it says I have 3 positional arguments and I've only given it 1, my tuple. But if I just make a change here and I give it star, it'll unpack that. So let's see what that does. So now it actually called it properly. And that's the reason why the star works. Here's another example. So the star is actually saying unpack, take all the arguments and unpack them and then pass them as they are, okay? And you can do the same with a dictionary. I'll give you that as an exercise. Why don't you try create a fake method, another fake method. So we'll call it fake method 2, def fake method 2. But this one will now take keyword arguments, and this is now where it becomes different. So I say A is equals to 1, B is equals to 2, C is equals to 3, and D is equals to 4. And I want to print again the same thing now. But the only difference is these ones here, these are 4 positional arguments, and these are 4 keyword arguments. Now, if I were to call this a fake method 2, I would have to specify. I don't really have to, but there's a way you can enforce it, and I don't want to go into that. But you could now say square, fake method 2, and I have A is equals to, let's say, 5, B is equal to 6. Okay, like that. Okay. So if I run this, now I get it works correctly. But if I wanted to pass in the arguments just the way I did with the tuple, but now I need to use a dictionary because I have to have the name. So I say my dict is equals to, and I have my dictionary. I'd say A is equal to, now their strings is equals to, A is equals to 5, and B is equals to 6 and 7. Sorry, I'm using the, now if I try and pass this here, I say my dict, it will now, again, the same error. Oh, it has worked well. It has worked directly. It should be, I should unpack it, ideally. So here again, our keyword arguments, remember we said keyword have a word associated with them. That's why they're called keyword, but it's just like using a dictionary. And therefore you need to unpack them. So the single star is for unpacking a tuple of positional arguments. The double star is for unpacking a dictionary of keyword arguments. In other words, you could create your arguments, put them into a dictionary, and pass them to a method or a function and unpack them, and it will work perfectly fine. So it's just that what we are doing here is we have, these are just the conventional names used, star args and star quags, and you see them in many classes. Let me just try and think of one so that you can actually, because I want this to be sort of concrete for you so that you can um oh man, Python documentation. I want it to go to the library because I want you to see how that works. There are some examples. I think they're probably in the language reference. Args, args, quags. Okay, inspect inbound arguments, argpass. Okay, so you see there are many examples where it is used. For example, in argpass. So this is a library that is used for building CLIs, command line. And here you see what they've done. Let me just find that. Args. Okay, quags. Okay, so for example, here we've created, there's a class, and quags means everything else. Like you can define your own keyword arguments on the fly, and it'll just pass those keyword arguments up to the super. Okay, let's just find another example. I want you to see that this is something that is used everywhere. Here's another one, OS, quags. So here is a function called fdopen, and it returns an open file object connected to the file descriptor fd. So you can read about that. But the point here is that this function allows you to pass anything else that you want to pass on. You can, as many arguments as you want. It's up to you. Okay, let's look at another example. Unitest.mock. Let's look for a nice one. Define programming FAQ. Okay. How can I pass optional keyword arguments from one function to another? So this is what it's even showing you here. Let me give you um, how do I pass? I want to get the question because I want to share this with you in the chat so that you can then read up on it. Because that's a great question. It's a bit abstract to begin with. I'll stop there for this. I think I've gone through a lot, but I hope that gives you a sense, a bit of an answer of that idea. Omolo asks, in the Canvas class, I haven't understood how the self.pen works. Great, let's go back to the Canvas class. And we are looking at it. So I'll just collapse this so that we want to understand how the pen works. So how does the pen work? So first of all, the pen is, so the reason why the Turtle library was created was to help to give people a concrete way to understand that programming has to do with what you put in. The computer understands nothing. It has no knowledge. It contributes absolutely nothing. You're the one who has to write out the algorithm. And you have to write out step by step. And therefore, what this library illustrates is that even for something as simple as drawing a shape, all the steps that you carry out are it's up to the user to do them. So if you remember from the draw circle, drawing with turtles, when we wanted to draw, here we're literally using the pen directly. So this draw circle is probably the best illustration. And we created a pen, which is turtle.turtle. And then we have to go through checking everything. And if you run this, you'll notice that, I don't know if it's going to run. I wish I can, it draws it on my screen. You can see that. I don't know how to force it to draw on the other screen. Is there an option here? Keep in dock. Assign to desktop one after desktop two. Let's try that again. No, it doesn't work. Yeah, it just ends up drawing on the, oh, here it is. I don't know why I did that. But the way the pen works is it shows you that even when you're drawing with a pen, you have to go to all those things you do intuitively, you have to make the computer do them. You have to say, create the pen, and then you have to check, is the pen on the paper or not? If the pen is on the paper, raise it so that it doesn't write, because now we need to go to a different location. If I remove these lines here, I think there should be a way to pause the turtle. Let me just see if I go back to the reference documentation for that. Is there like a sleep? Is there like a wait? There should be something like a pause or something. I'm looking for a method that allows you to, so that I'll have enough time to bring it to the screen for you to see it doing the drawing, because that's really what I want you to see. Reset right, show turtle, hide turtle, is visible, shape, reshape, tilt. Oh, on click on release on drag. Okay, and I don't want to go into some of these now because I don't know how they work. Screen size, set word coordinates, delay. There we go. There we go. Set or return the drawing delay in seconds. So turtle.delay. I'm going to put a delay enough for me. Actually, I can do that right. You know, I can do the simplest thing in the world. I can do a sleep. Import time. And then I can do a sleep. So I'll do time.sleep. And I put 2 seconds. That's enough time for me to draw. So let's see what this does. It'll sleep. And then, now you see that's what it has done is very different from what it did before. It moved with the pen down. So it ended up drawing. While if we uncomment this and we run it again, it's different now. I don't know why it's doing this now. Now it doesn't have that line. Does that answer your question? So the same thing, the pen in the canvas will do the same thing. It'll belong to the pen. And when we look at polymorphism, we will see how to transfer the pen over to the shapes, because now we want to give the shapes the responsibility to draw themselves. That's where the polymorphism. So if you draw a square, a rectangle, a circle, you just tell it to draw itself and it is responsible for drawing itself. That's where polymorphism comes in. Okay, I don't know if I've answered your question. Let me just see any other questions. Yes. Oh, great. Excellent. I'm glad that made sense. Okay, thank you, Amolo, for clarifying that. Okay, good. Owen, I've noticed that when you are trying to find why the code, specifically the canvas class, did not work as expected, you are interchanging the lines of code initially. Does it mean that Python interprets and executes code line by line? Yes, it does. So Python is an interpreted language. It's not a compiled language. And that means a number of things. One is some of the errors are only discovered at runtime, which is a big disadvantage. And that's one of the reasons why you need to learn something like something called test-driven development. With test-driven development, you sort of guarantee, you check the code before you run it. You write tests, and those tests are part and parcel of your code. Because you don't want, and what has happened with Python is that over time they have added a lot more sophistication to the language. So for example, let's come back to the drawing with turtle, the OOP circle class. Now notice here in the canvas class, for example, we've specified that width is 1200 but that can be any type. Now, in newer versions of, in the newer approach to writing Python is you actually specify types. You can specify types both at the input and at the output. So here we'll specify that this has to be an int, and we specify that this has to be a string, for example. And as you're writing your code, you can then check. It can allow you to check. So for example, if I say canvas, okay, so here's my canvas, and I give it, and I say the width is a string, 37, it already starts flagging to me in advance. It expected an integer. I don't know if you can see that. It expected an integer but got a string instead. This improves how Python operates, even though it is still under the hood. It will still be an interpreted language. The way it operates, it requires it to have that flexibility. And that's one of the things that makes Python, learning Python very easy. That right from the beginning, you don't have to think about different types. But if you go to a language like C or C++ or Java or Go or Rust, you work with types from the beginning, because at compile time, the compiler will check for invalid types between functions or during instantiation of different things. And then your code will not even compile. So that when you run it, you are sure that the type check that run as part of the compilation found out all those errors. That's not the case with Python. So that's why they're now introducing these type signatures, which are not operational. They are purely for you to help you when you are working with an IDE. But you can also use them to enforce type checking, even if those types are not going to be correct, going to be actually used. I don't know if that answers your question. Yeah, so Python interprets and then executes line by line. I don't know if it's line by line though, but it does. Yeah, it does. It is line by line. So you can discover errors in your code, even if your code base has been running correctly for years. And that's a painful thing. But by writing unit tests, you can avoid that. Okay, let's see. Any other questions? How did you describe the bounding box of a rectangle? That's a great question. So let's actually draw this and try and figure out. So when we drew the rectangle here, so we gave a number of parameters. And let me try and I'll draw on my screen, and hopefully that's going to help. So if you have a rectangle, so let me just get a pen. So I'll draw a rectangle here, and I will give you a number of assumptions that we've made. So we have a couple of parameters that are defined here. So first, we have the width, the height, and then we've got the position. So the first assumption, remember, if I said this is, what is the actual position? Now, suppose we defined that this vertex here would be your position. So that means that this is actually sitting with its bottom left vertex at the origin. So this would be 0, 0. And then we have the width, which we've specified. So let's say the width is W and the height is H. Okay? Now, if we want to calculate the bounding box for a rectangle is essentially the rectangle. So a rectangle isn't probably the best example of this. But the bounding box would be the set of coordinates that define the box that contains this shape. So that means by default, if this is sitting on the origin, then that is already one coordinate of the bounding box. And that is another coordinate of the bounding box. But the way we've defined it here, if I can just open this up so that you can see. The way we define the bounding box here is we are just getting the coordinates of the bottom left coordinate and the top right. I think in this particular case, we defined the bounding box so as if the origin was in the middle. So then maybe that's where the confusion is coming from. So imagine that this is the origin. So this is where your 0, 0 is. So that's the position. So this is not then going to be that coordinate. So if we were to calculate what are the coordinates of this point and what are the coordinates of this point, because those completely define the bounding box, then how do we get this point? This point is going to be halfway across the width. So this is W over 2. And so that's that from the coordinate. So this, we know that the x value here will be minus w over 2, right? And what is the y value? Well, it's going to be the height h over 2, but it's now negative because we are from the origin. So this will be minus h, the height over 2. And then the same thing for this side here. This one now will be the other extreme. So this will be w over 2, and that will be h over 2. And that's why we end up with this. So it was the position, because the position here is 0, 0, we're just subtracting. So this value here, position 0 is actually 0. So 0 minus the width over 2 is minus width over 2. 0 plus width over 2 for the x marks is just w over 2. And the same thing for the height. Does that answer your question, Damaris? Okay, any other questions? So it's interesting that there are so many questions now that a good number of the class has dropped off. That is strange. Any other questions? Because we still have another 11 minutes. So if I gave you an exercise right now to, let's see, has everyone managed to get their code to run? Can I get thumbs up? Just a sense of those who in the class have managed to get their code to run. Okay, then if you haven't got your code to run, please, 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 for your own good, I'm only telling you this because try and do this in the course of the class. Because this time is set up. Okay, thank you, Jordan. Well done. This time is set up for you to learn this. And if you do it now, you're not going to have to look for time in the future. The time in the future has got its own things. It will have all the attention. Everything will be baying for that time's attention. So if I were you, whenever you have a class, try and use that class to learn from it. So if you don't have any questions, I'm going to stop here. And then we're going to meet tomorrow. And then tomorrow we'll now be talking about polymorphism. I'll try and set a couple of exercises for you to do for this. I don't think I have it. I think maybe the best thing is to just run the code. Everything is now already pushed to the repo. Let me just push the latest changes. I don't know what I've changed. Okay, I can, this is sleep. And opacity, okay. Trivial changes. And I'll commit and push. Okay, so those should be up to date now. If you check on the repository, you'll have all the latest changes are there now. We have for the rectangle, we now have the stroke width. What else did I add? It should have been an opacity. Oh, I'm looking at the wrong. Oh, cycle. It should be opacity. There it is. Okay. So those are the latest changes. Okay. Otherwise, have a great day, and I will see you tomorrow at 2. Bye.